We'll continue to look at examples of functions that require a rewrite before we can apply the basic derivative rules that we've developed so far. Here's one that involves fractions, and the main thing to remember about a fraction is that if you have a power of x in the denominator of a fraction, then that's really the same thing as having a negative power of x. These two things really mean the same thing. So when we have 1 over x to the fifth, that's the same thing as x to the minus 5. So the rewrite here that we could do, again, I'm just going to abbreviate rewrite RW. The rewrite would be to say that f of x is x to the minus 5 plus 4x to the 1/2. Notice that the second term doesn't require any kind of rewrite because it already looks like a number times x to a power, which is all we really want to have for our rules. Once we have every term looking like number times x to a power, then my rules say to just apply the rules to each term one at a time. There's no number in front of this, so there's nothing to worry about there. The derivative of x to the minus 5, the minus 5 power comes in front, and then the new power I get should be 1 less than the old power. So minus 5 minus 1 is minus 6. So I'm subtracting 1 from negative 5 and getting negative 6. The second term has a 4 multiplied in front, so I bring the 4 down. And then the power rule says that the derivative of x to the 1/2 is 1/2 x. And again, I have to subtract 1 from a half. I already did this in the last video, so I remember that 1/2 minus 1 is negative 1/2. So that's my derivative rule. Again, when you're entering it into a calculator or a computer, it makes sense to go ahead and simplify, at least in the sense that if you have two numbers multiplied together, you should go ahead and multiply them. Or if you have two terms that are the same kind of term, you would add them. But here 4 times a half is simply 2. So it makes sense to get rid of all the parentheses by at least multiplying out the things that are just numbers. So this would be a good final answer. Here's another one with the same basic idea, but here we have something a little bit different going on because this fraction is not just 1 over x to a power, it's actually got a number at the top and then power at the bottom. So for this kind of thing, the fact about fraction that's good to remember is that a fraction really is division, and division is the same as multiplication. So a over b is really the same as a times 1 over b. So the reason that this is useful is that it allows us to separate the numerator from the part that involves the denominator as a multiplication. And remember, our goal is to make these things look like a number times the power of x. So if we have a power of x either in the numerator or the denominator, this is going to separate the power of x from the number. So here, for example, again, this is just a rewrite. We're not doing a derivative yet. My rewrite says that 4 over x cubed is the same as 4 times 1 over x cubed. So that's just what the fraction represents. The other parts, of course, are fine the way they are. And this is sort of a double rewrite because we saw in the previous problem that we don't like the power of x in the denominator. What we'd rather have is represent that as a negative power of x. So 1 over x cubed is the same as x to the minus 3. So after a couple of steps here, we have a rewrite for our f of x, which means we're finally ready to find the derivative. The derivative in this case are 4 stays where it is. The derivative of x to the minus 3 is negative 3 x to the minus 4. 1 less than negative 3 is negative 4. And the derivative of 2x is 2. And the derivative of the plus 3, that constant, that 3 is not multiplied by any powers of x, so the derivative of that plus 3 is just 0. So again, we can rewrite that for the sake of course compass, but I won't waste time in the video doing that. This one uses the same idea. As you can see, they're getting a little more complicated. But we're not really complicating the ideas, we're just having to do the same idea more often. The rewrite here, again, these are both fractions. Well, the first one's a fraction that actually has an a and b. So again, I can separate the numerator from the denominator. So just like I did before, I've made this x cubed times a seventh. Now I've written the 1/7 first because I like to see this as a number times the power of x, but really it's still just using this fact up here. The second part, that's 1 over a power of x, and so I don't have to play any games with the 1. I know that if I have 1 over a power of x, that's the same as just x to the negative power, whatever the power is. So I've had to do a rewrite for both terms here, but now each term does look like just number times power of x, and so I'm now in good shape. I leave the 1/7 alone. The derivative of x cubed is 3x squared, and the derivative of x to the minus 1/2 is negative 1/2 times x to the minus 3/2. The minus 3/2 there, remember I have to subtract 1 from the current power. So the original power here was minus 1/2, so subtracting 1 from it gives me negative 3/2. The last two examples here are really a matter of just using the distributive property to simplify something first, rather than having fractions, negative exponents or fractional exponents. So in this case, just doing regular multiplication, we could use FOIL or whatever, but this is just straight multiply the x squared through the distributive property. So my rewrite here says that my f of x is really 3x cubed plus 7x squared by multiplying that x squared term by all the other ones. And then it's easy after that. Similarly, here, I can think of this division is distributed. Whenever I have just a single x in the denominator, or single power of x in the denominator, then I can distribute that division across each term in the numerator, and that's x plus 2x squared. And again, once I have that rewrite, this is just the rewrite, once I have that rewrite, then finding the derivative of this thing is very easy.